Hello and welcome to a BCS Level 4 Diploma in Data Analyst Concepts. This video, the first video, will focus on the types of data and we'll look at Objective 1 within the syllabus. It will be presented by myself, Lee Holroyd. Okay, so within this video, we're going to look at three different areas, which again are highlighted within the syllabus. The first one is describe the differences between data, information and knowledge. The second one is to understand and explain the range of different types of data and the implications for allowable use, data quality, privacy concerns and availability. And finally, we will look to understand the importance of data classification and describe how to classify data, which are structured and unstructured data, quantitative data and qualitative data. Okay, so within this video and presentation, we will look to cover these three different areas. Hopefully you've all got an understanding of some of this anyway. We all know what knowledge is and we all know what data and information is. It's just making sure that we're on the same wavelength as BCS. So when you come to take the exam at the end, then you know the terminology that they're going to be using and what they're going to be looking for. Okay? So the first area, we need to describe the differences between data, information and knowledge. The Oxford Dictionary defines knowledge as the information gained through education and experience. However, in business and other disciplines, we generally differentiate more explicitly between data, information and knowledge. So in our day-to-day lives, we classify knowledge as an overarching thing which we just know based upon different things. Within business, we need to separate that in between these three areas. So we've got data at the bottom, and then data leads into information, and then information leads into knowledge. And then generally you'd have wisdom above knowledge as well. But BCS don't need to know that. So these three different areas, what are they? Data. Data is facts and figures which relate to something specific, however, are not organised in a way which provides further information regarding patterns and context. So here you've got four pieces of data. These pieces of data at the moment say 10.5%, 573 billion, second, 223 billion. These are all pieces of data. However, at the moment they're not organised in a way which allows us to read them or process them. Secondly, we've got information. Information, when we give data a context, a category or content, it becomes information. Information is data which is relevant and purposeful. It may convey a trend or indicate a pattern, for example. So if you look at our picture at the bottom now, we've got exactly the same pieces of data as we did a minute ago. However, this time it gives us some information. This one is about the euro to the yen. It's about data based upon money because of that. So in the blue section, you'll see here, we've now got 573 billion, the total value of traded goods in 2017. That's give it context. It's now become information. Okay. We've got 223 billion total FDI, inward and outward stocks in 2016. Second, China is the EU's second largest trade partner. And then finally at the end, we've got 10.5%. And now, because it's information, it says that China's share in EU trade in 2017. Okay. And that is all now information because it allows us to process that data, give it some context, give it a category, and then condense it to become something useful and purposeful. So after we've got data and information, we've then got knowledge. Knowledge is a fluid mix of framed experiences, values, contextual information, expert insight, and grounded intuition, which informs information can be passed towards. I don't know why within that I've made that picture too big. So it's around, with knowledge, it's about looking at the data and the information itself and then bringing together that information with your expert insight and your grounded intuition and your contextual information. So we could have, for instance, information on students. We could have loads of different information on the students, which is grounded based upon data. So we've got data on student A, which is 6'6", a number based upon their student number, a geographical background, etc., etc. That's brought into information, so it says height, etc. So we've got that in a structured manner, and then your insight then is to put them in a certain class. So you could, for instance, if they had high needs, you could put them into a category based upon your knowledge, and you could look at the trends and bring it all together based upon how you would perceive that information and your contextual information and your expert insight. Okay, so knowledge isn't a thing that we can read, and it's not something that we can learn how to do it, definitely based upon our job roles and our environments, but it's something that isn't like data and information where it can be written down in fact. It's something that you need to consider based upon a load of different things. Okay, so we've got these three different things. We've got data, which is numbers, basically numbers and pieces of data or facts and figures. Then we've got information when we give that data context based upon something such as a category or some information or a relevance or a purpose. And then finally, after we've got that information, adding your contextual information, your insight and grounded intuition, this then becomes knowledge. Okay, and then you would have, in a long scheme of things, the wisdom, and wisdom is looking at knowledge and then predicting insight and looking forward of how you would perceive that, and then based upon a broad range of contextual information. But for the purposes of BCS, you just need to know terminology and definitions for data, information and knowledge. So again, knowledge is something we use in our everyday lives all of the time. Sometimes this relates to know-how, sometimes wisdom, and other times we directly refer to data and information. So we could be talking around a subject as knowledge, and we could refer back to some information that we know or some data that we found. Okay, so these things all interline. It's just working out that hierarchy that we need to be familiar with. This being said, in business and data analytics, these definitions of terminology for data, information and knowledge are commonly used. So these are how BCS and in data analytics you would generally split them up. So we've looked at different types of data, information and knowledge. The next area is the typical formats and sources of this data. Okay, so within BCS itself, BCS highlight CSV, XML, RFT and text as some of the most commonly used formats in which data can be stored within. There are many more, however, understanding formats of data will allow you to understand how to work with data. So that last bit's really important. Understanding formats, it doesn't just mean you can open it on your PC, it means that you can understand data and you can use it in a certain way to allow you to do what you want it to do. Okay, so data is just a thing that we can work with. It's understanding how we work with it, which makes you data analysts and it makes you data scientists. Okay, so a bit of terminology, data transformation, and this is the process of converting data or information from one format to another, usually from the format of a source system into the required format of a new destination system. So we could, for instance, take some data in a CSV file and we could import that into an XML file, and therefore we have conducted some data transformation. Okay, you might have done this already in your job roles and you might be familiar with how to do it to an extent in different ways. However, the terminology for this is data transformation, so make sure you've got a note of that somewhere. So the first format we're going to discuss is CSV, or common separated values. So CSV is a spreadsheet file format. Data is stored in cells and generally organised in each cell in rows and columns. Importantly, a column in a spreadsheet file can have a different type. For example, a column can be a string type, it can be a date type, or it can be an integer. So for each one, as you know, working with Excel files, you've probably all done this, you can set them different cells to contain different parts of data. And because we've set it that way, it means that we can withdraw that information and when we can use it in different types of files. So at the bottom here, we've got two little screenshots. On the left, we've got a screenshot of an Excel document. which just has some different columns and some different data within. So it has numbers here and it has addresses, some strings and some more numbers, etc., etc. And then at the end, we can export that as a CSV file like this. And what it does is it records, this is a different piece of data, but it records columns here. So it could be longitude, latitude, city name. And then within that, it records each record. So a record is a line of data. So a line of data. It records each record separated by a comma. Okay. So we've got 145.768, and then we've got a comma after that. Okay. So a CSV file or comma separated values, that's what it is. It's a type of spreadsheet file format, which is really commonly used. You've probably used it quite a lot just as an Excel document. So a CSV file, but you can export that type of data and you can load it into databases and different back-end systems to do loads of different things, okay? But for the need of this terminology and the need for BCS and your exam, you need to know that it's a common separated language and it's a semi-structured type of language. So that means that it has columns and rows and it has names for each one of them. And then there's a way of exporting it such as this. And then it prints it out in a text format with commas that are separating them values. Okay. Next, we've got XML. XML, also known as the Extendable Markup Language, is a human-readable and machine-readable file format. So it's human-readable, we can understand what it says, and then machine-readable, obviously PCs can understand what it does as well. XML is a self-descriptive format designed for sending both content and structure generally for websites and other platforms such as this. So self-descriptive means that XML, it uses a tag-based system which you can set each one of them tags yourself. So you can set them up however you like if it follows the hierarchy which we'll discuss in a second. XML is very similar to HTML, so Hypertext Markup Language, but has some differences. For example, XML does not use predefined tags. So for instance, in a HTML page, so a HTML page is just an internet page. Within the background of that page, it has tags, so it has div tags. So for each one of them tags, it'll have a certain name which it can do. So it might have a header, so it might have head at the top, and then whatever you put within that tag will show on the web page at the top in the header. XML doesn't have predefined tags, so you have to design them yourself, okay? So here are two quick examples of an XML sheet. So on the first one, what we've got here, it looks quite complicated, but it's not. Everything within red are tags, and everything within black is data that you've put into them tags. So we could have here, we could have a tag called job, and everything within job, we've got two more tags which are production and customer. So for every tag, so job here, we've got a closing tag. So job, job, production, production, customer, customer. So this type of XML file could be used for something like Amazon, and it could be showing what that person bought. So for instance here, we've got approval type, web center, we've got substrate as in a carton, 150, sheet size, what the press is, what the finish is, and the urgency of this. That's the production element of whatever they're buying. The customer, it could be for Fruit Co, it could be their unique identifier, which is 2712, and then the currency that they're operating with is US dollars. So this is a set of information which has been outlined, and it's outlined in XML using their own set of tags. Obviously that can be really, really important, and it can be really, really useful because XML can store any type of data. It could store data from what types of dog you've got. It could store data for what's in your fridge. It could store data for a sales website like Amazon. It could store data for a game or a film or Netflix or a backend for a website or a system for a college. There's loads of different things that XML can do. What this does is it allows you the freedom to design your own tags. Okay. The one thing that you will consider, and when looking at XML, it works in a hierarchy from left to right. So you've got job here, which is indented. Then the next set of tags are indented, and then so on, next one indented, and it would continually to go like that. What that means though is when we're starting to create XML files, they can get very big very quick. Obviously this has only got two types of tags. If we had, before this job one, if we had an Amazon website for instance, then we had job, and then we had production, and then we had approval type, and then we had where it was approved, etc, etc. Eventually it could come all the way down, and when it comes all the way down here, we'd have to go all the way back again. So these pieces of data and this format can get really big really quickly. Okay, so understanding how XML works just allows you to do these different things. Another quick example on the right, here we've got parts, which is an overall hierarchy, or just think of hierarchy as a category within this sense. So we've got an overall category, and then inside this we've got a range of different categories. So we've got parts, and then we've got part, and then a part, and then a part. Each one of them has got a different ID. It's got a different name for that part, and then the total available is different as well. Okay, so this could be like setting up a website to sell something, and then within the parts category you've got a range of different parts you can use as well. Okay, so that's what XML is, and it's a way of creating code to allow you to do these different things. The next one is RTF, so rich text format. RTF is a text file format used generally by Microsoft products such as Word and Office. RTF, or rich text format, files were developed by Microsoft in 1987 for use in their products and for cross-platform documentation interchanges. RTF files offer some formatting features such as bold, italic, underline, bullet points, different fonts and text justifications. However, it does not provide all of the features found in a general word processor such as Word. Okay, so I know this is a picture of Word, but RTF is the file type, and this has just been opened within Word. So it has a range of different formatting options, such as bold and underlined and italics and all these sort of things, which are a way of structuring data. So even though like you won't really think of them like that, maybe when you go into Word and you put something in italics, it's basically making a backend tag which says this is in italics. So then when we transform data, we can transform data which has got lots of different bold headings within Word into another file format, and we can take that data with us to allow us to categorize it. So that's one thing to consider, and that's RTF. And then the final one that BCS want you to consider is text. So in plain text file format, everything is written in plain text. Usually this text is in unstructured form and there is no metadata associated to it. The text file format can easily be read by any program, but interpreting this data can be very difficult by certain computer programs. Text files are useful for storing information in plain text with no special formatting at all, beyond the basic fonts and font styles. The file is commonly used for recording notes, directions, and other similar documents that do not need to appear in a certain way. So underneath here, you'll see a simple text file which has got some placeholder text in it. In this file format, there is no categorization, so you can't put it into bold, you can't put it into columns, you can't put in any structure at all. But also that works in a positive way because it's simple. The file formats are generally really, really small because it doesn't need to take this range of different data with it. Okay, so you've got the 4 different file formats that BCS want you to consider within the exam and in general to start off with. So you've got CSV, XML, RTF and text. Obviously there's a lot more different types of files, and generally you'll start to use files when you're doing a certain thing. So for instance, if you're recording some data from pictures, you're going to use JPEGs, and you're going to use PNGs, and you're going to use PDFs, and a lot of the data formats and different file types relate to the task that you're currently doing. Okay, the aim is to get that data out of that format and into one of the commonly used ones in order for us to do data analytics, such as CSV. Okay, So looking at the benefits and limitations then, we're going to focus on two. We're going to focus on CSV and we're going to focus on XML. The exam itself will generally focus on these anyway because these are the most commonly typed used within data analytics. So we're going to quickly run through the advantages for CSV and the disadvantages. So CSV is human readable and easy to edit manually. So we can read it as human, and we can easily edit it in something such as Excel. So we can nip in it, we can change some data or some structure very simply, and then we can save it and it's done. CSV is simple to implement and parse, so it's easy to use in a certain way. So we can use it into different R programming languages, for instance. We're going to export it from an Excel file into an R programming file, and it's a very simple thing to do. And from that, it's easy to take strings and text into a different language, and we can modify it such as that. Then we've got processed by almost all existing applications. Provide a straightforward information schema. So a schema is basically a structured file. So we might have a CSV file, for instance, which has got all the context, and then such as data itself. And then we might have another CSV file which works alongside that, which just shows the structure, so it shows the rows that should be there and the columns that should be there. That's more prevalent with XML as well. CSV is fast to handle. It's generally small in size. It may be considered to be a standard format, so a lot of people around the world generally use this format. It's compact. For instance, for XML you start tag and end tag for each column and each row. In CSV you write the column header only once. So like we said before with XML, you open it and close it. You don't need to do that in CSV. You just open it with a certain column and it will understand that. And CSV is easy to generate. So it's easy generally when you put data into a CSV file, we can export it dead easy and we can open it dead easy. Some of the disadvantages with CSV files are that it allows to move most basic data only. Some complex configurations cannot be imported and exported in this way. So if we're storing complex pieces of data, sometimes CSV files will struggle. There is no distinction between text and numeric values within CSV files, so that this is one of the main hindrances with it, and that's just because of the way it's read. Even though you can set certain cells and columns to different things, it still can't differentiate between text and numeric when it's being exported. No standard way to represent binary data. Problems with importing CSV files into SQL. There's no distinction between null and quotes, for instance, which are two terminologies, which mean null means zero or not allowed, and then quotes means picking up a certain part of that data, but we'll get into that as we go along. There's poor support for special characters. Within CSVs generally, you have to use some of the tools to allow you to use special characters, and it generally has a lack of universal standard. So as you will know yourself, every Excel file that you open will be different. There's no standard ways of doing anything. There's no standard columns or sizes, etc. Every company generally makes their own standard versions of doing things, which is good to an extent, but it can be a big disadvantage when you start to work in bigger areas and you start to work with national and international systems. So XML's advantages are generally it's platform and programming language independent, so it doesn't work on any specific platform. So it doesn't work on like a specific browser such as Google and Firefox and in the Explorer. It doesn't work on just Macs or just Microsoft or just Linux, anything like that. And the programming languages it works with is anything. It works with like C++ and Python and R and SQL. It works with all these different areas of programming languages. Additionally to this, XML supports Unicode, and Unicode is an international encoding standard used in a range of languages and scripts. This also means that XML has the capability to use every human language in the world, so some programs and some file formats will struggle with different human read languages, whereas XML won't because it allows Unicode support, which means that it can use a range of different characters in order to work. The context of an XML file can be changed whenever required without changing the presentation and structure of the data. This is one of the most important things when using XML. So within XML, you will have a schema. So a schema, as discussed, is a structure and a set of presentation elements. So you might have, for instance, in Amazon, let's use Netflix. In Netflix, you might open up Netflix and it might have a list of different films. With the XML schema, you could have it set out so that, for instance, you might have title 1 of film, and then you might have description of film, and then you might have rating of film, and then 3 things for each one. The structure of that is exactly the same for everything. All you then have to do is go into your XML file and change the context or the data. So you might have to change it from one film to another. You might have to change the actual description, but the structure around it won't change. And that's really good for standardization and bringing in certain types of data together. So as it says, it allows DTD and schemas. This basically validates that XML code is written correctly as well. So you can create schemas which will check the code, just check the validation and make sure that it's running correctly. So as we've seen on this picture before here, it will run this code and it will make sure that that matches that matches that, and then so on. Okay. XML is multi-platform and therefore it's easy for the file type to be conversed between systems. So XML, as we discussed, is platform independent, and therefore it allows multi-platforming, and different systems can read the XML file simultaneously and really well, which is really important. XML disadvantages. XML can be really wordy and redundant to some of the more fluid format types such as JSON. So XML itself, as discussed, can get really, really big. If you've got 6 different tags and each one of them tags has got another 6 different tags, then we start to multiply really quickly, and then from that it can get really, really big with regards to file type, and also towards your resource time for reading it and then typing it out as well. So XML files can be large, and transportation costs can be huge when the volume of data is large. So the costs of moving that data, so if the data is 600 gig for instance, if you have to download that to a system or read it from a system simultaneously or over a certain period of time, then the resource requirements for that could be really huge. So it's something you need to consider when you're choosing this file format for your projects. XML files, even though they are readable, are not as readable as some other formats. So even though we can read this file format as we went through before, there is other file formats which are easily readable, and then this one is a bit in between. XML files can change in size dramatically depending on the programmer. So again, as we discussed, the file format and the size of that file, if we design this a different way, so if we had job and then we had production, and then inside approval type we had approval name, so we just created an extra 1 inside here, that would mean that for every single piece of record it would have that extra stage added to it. So the programmer themselves, when they're creating XML files, needs to consider stuff like the cost of that resource and then the size of that file, and therefore the dramatic size difference can change because of that. And then finally, one of the disadvantages is XML does not support arrays. So an array is like a 3D list. So think about noughts and crosses. Noughts and crosses is a 3x3 array. So it's got 3 pieces of data across and it's got 3 pieces of data below. XML doesn't support that, so again that makes the file size much bigger. And then finally, right at the bottom, we've got RTF and text. So we're not going to go massively into the benefits and limitations of these, as they're generally pretty simple. So RTF is a text-based operation with such formats as list paragraphs, bold, italic, and it has different characteristics that you can add to that text to make it stand out and give it a category. So for instance, you could put heading 1 and put that in bold, and then that would record that as a category of a context, and then you could export that into a different file format, and it could use your information that you've give it, such as making the title bold, to allow it to export in a certain way. Then you've got text. It doesn't support any formatting at all. However, this is a good thing because it makes it really, really simple, and it's also a limitation because it doesn't support any formatting at all. Okay, so these two things at the bottom you just need to consider in different ways. Okay, so the next area we're going to look at is structured and unstructured data. So now we've looked at data, information and knowledge, and we've looked at different types of formats. We need to actually look at the data itself and consider a few different things. So structured data is highly organised information that uploads neatly into a relational database. Think traditional row-based structures. This data generally used a method of analysis such as VLOOKUP or SQL to perform queries and actions on the data. This type of data is used in the company's format and as such can leave out information when the analysis is taking place. And this is a consideration for structured data. So structured data basically is an Excel document. So any Excel document which is a CSV file would have a structured setup, and it would have a range of different data which you could then edit and you could run queries against to allow you to find information. Some of the considerations to make within this are that when analysis is taking place, issues with the structured data are common, especially with data entry and human error. So obviously within structured data entry, there's a massive human error element because people are entering that data within that structured data section. So working out ways of carrying out this operation without the human element can be important. Unstructured data may have its own internal structure but does not conform neatly into a spreadsheet or a database. So unstructured data, while it's unruly in nature, is also incredibly valuable and increasingly available in the form of complex data sources. These are generally elements such as weblogs, multimedia content, emails, customer service interactions, sales automations, social media, most business interactions, in fact, unstructured in nature themselves. So it could be a conversation that you have with someone. It could be an email that you've received. It might be a video that you've been sent or a picture that you've got. This is all unstructured data. There's loads of data within that. There's loads of information that you can create from that data. However, at that stage, it's unstructured data because it doesn't have the capability of being read or looked at by some of the different systems to allow it to read it the same. Okay. So what we're going to do is we're going to break these down a little bit more. So we've got structured and unstructured data here. The chart below shows 4 types of data structures, with 80 to 90% of future data growth coming from non-structured data methods. So that's quite an interesting fact when we come to data analysis, which we'll look at in more detail at another stage. However, it's important to consider that most of the data that we take from the world these days is all unstructured data. So it might be to do with like video camera surveillance. For instance, there's like 400 petabytes of data which are recorded every minute from security cameras. And then all that security camera footage is multiplying and multiplying. So that's just an example of how some of this unstructured data is becoming so big. Okay, and that's when we get into stuff like big data. So big data in essence is a set of data which your organization cannot handle. So when we're getting into certain types of data, we need to start looking at warehousing and stuff. But we'll get into that into a lot more detail. Through the four are commonly mixed. Let's use an example of relation database management system for the software support call center. So we've got these different types of data. So a structured data could be a call log characteristic, which has got timestamps, machine type, problem type, and operation system. So we could get this information from a call center. So someone could ring up and say, right, I've got a problem. Here's the time which is recorded on the call. Here's my machine type. Here's the problem I'm having. And here's the operating system I'm working on. Within that conversation as well, you've got unstructured data. So you've got some free-form call logs, sort of information. So you've got some different information that you're talking around. You've got your customer chat history, and you've got a transcript of the phone call itself. So even though you've got a lot more data in the unstructured, again, this can be quite hard to read. So it's something you need to consider. And many insights into data can be extracted from the unstructured data in this support centre rather than the structured centre itself. So if it was a proper call centre for an IT system, for instance, if you had timestamps and machine type, that's important, but it's not as important as looking at the customer chat history or the transcripts of the phone calls, or understanding in a bit more depth or context as to how this data could be used. So we've got our unstructured data, which is right at the bottom, and then we've got our structured data, which is right at the top. So we're trying to, generally within data analysis, we're trying to take unstructured data, or whatever data we're using at that time, and we're trying to make it into structured data. Structured data is the easiest thing to analyse in the world. Unstructured data can be really tricky. So it's working out the ways in which we can do data transforms and make this work. Okay. So you've got structured data containing the defined data type format and is structured, that is transitional data, online analytical processing, or OLAP, data cubes, traditional databases, CSV files, and even simple spreadsheets. So on the right hand side there, you've got a simple spreadsheet, and within this spreadsheet it has different types of columns, and these different columns represent different sets of data. Okay, so this is a structured way, and we could do some analysis easily based upon the number of sites and the meals served. It'll be an easy comparison to do within that because it's been structured correctly. Then we've got semi-structured data, so textual data files with a discernible pattern that enables parsing, such as extendable markup language, data files that are self-describing and defined by an XML schema. So here you've got it's a semi-structured set of data which we've recorded within an XML style structure. So we've got a game here, which is our overall tag. Inside that we've got title, platform, description, image. When we run that, we'll see here we've got game title, which is this, platform, which is here, and then we've got description, which is down below, and so on. For each one of these, it shows the tag name, so it shows the game title tag, and then it shows the information within that. Okay, so within the semi-structured method, there are definitely positives that we can take. It would be easy to take some of this semi-structured data and make it into really structured data if we wanted to as well. So it's a passage on the way to structured elements. And for some of the outcomes and visualizations we need, semi-structured can be really useful. After semi-structured, we've got quasi-structured. Okay, so quasi-structured data is textual data with erratic data formats that can be formatted with some effort, tool, and time, or patterns in this case. So below, there's a set of 3 URLs reflecting the websites and actions taken to find data analyst information related to EMC. So together, these comparisons are a click stream that can parse and mine from data scientists to discover the usage patterns and uncover relationships amongst click and areas of interest on a website or a group of sites. So that's BCS's definition. What it actually means is, here are 3 different websites. So this person has gone to this website first. They've gone from this website, Google, onto the EMC website here. And then from this EMC website, they've gone to this page within that. That shows a clear pattern, okay? So quasi-structured data is looking at patterns within actions. So looking at the action from this website to this website, and therefore it structures data and it gives you some form of data which shows this, okay? This could be really important if you were creating like a marketing strategy for, say, a college website. So you could look at the college website, you could work out where people started on the college website, where they went to next within the college website, and where they ended up finishing within the college website. You could look at this data, and then you could work out some different methods of trying to steer people to a certain area of the website in order to help them find what they're looking for, or in order to advertise something to them, for instance. So this type of data can be really useful sometimes. And it could also work to look at the data of trends of people visiting different things or doing different things. It might not be a website, it might be that they go into one place and then go into another place afterwards, and then after they go to that place, and you can track this through a security camera. You can track it through a loyalty card, for instance. So loyalty cards are really interesting because the reason you have a loyalty card is because everything you purchase and where you purchase it is tracked. So even though you're using the loyalty card for discounts and you're getting a reward from it, the shops themselves are finding out lots of data which you will have signed up for when you bought your loyalty card, and then because of that, they'll be able to track different patterns that you do within shops, for instance, and then they'll be able to change things around to suit the wider public, and then hopefully to increase sales and stuff like that. Okay, so that's what quasi-structured data is. It's not actually looking at data itself, it's looking at patterns within data or within actions in order to find data. And then finally, you've got unstructured data. So unstructured data has no inherent structure, which may include text documents, PDFs, images, and videos. Information can still be recorded from sources, however, it's often more difficult to analyse until turned into more structured data. So we've got 3 different examples there. We've got a picture of 2 little elephants, one big elephant, one little elephant. Within that image itself, there's lots of data. So you've got a big elephant, that could be one. You've got a little elephant, that'll be another one. You've got grass, and you've got background, and you've got size of the light. There's loads of different things you could take from that picture, which are really, really important. You've got, just above that, you've got a PDF document of an article, which isn't structured. And then from that, you could take information from that. You've got a video on the right-hand side. Videos are one of the most commonly used unstructured types of data now. So within this, the presentation itself is a video, obviously. There is so much data of different topics that have been discussed, different times of different elements. There might be the volume or the size, and all these different parts of data that you can take would have to be structured in order to allow you to do analysis on it. Obviously, there's metadata behind videos as well, which we can use, which is structured elements from videos. However, that's a bit different. And then finally, you've got PDFs. So there are 4 types of data which BCS needs you to understand, and are really important anyway when we come to data analysis. So we've got structured data, semi-structured data, quasi-structured data, and unstructured data. Now, looking at the data itself, we need to look at 2 different key areas. We need to look at quantitative data and qualitative data. So quantitative data gathers data in a numerical format which can be put into categories or rank order, or measured in units of measurement. This type of data can be used to construct graphs and tables of raw data. So quantitative means numeric numbers, different elements such as that, which can be categorized. More importantly, they can be categorized, or discrete data, as they have defined values. It could also be continuous, so this is data that has an infinite number of steps which can form a continuum. So continuous could be something such as wind speed, and different elements which can have a massive range of different values. So it could be stuff like weight difference to 8 decimal places before cooking. It could be wind speed, because there's that many different answers there could be to that. It could be water temperature. It could be volts of electric. It could be, generally, it's with decimal places, and there is a huge amount of different types of data that you would not necessarily create the categories themselves to start off with, but they would have categories, and they'd have data that you can easily analyse. Whereas like categorical data would be stuff like how many eggs are there, or how many likes are there on that post, etc. So discrete and time series are two different terminology elements that BCS use that you just need to consider. So a category is something that you create in order to put data within. Continuous is looking at data, and the category themselves isn't created because there's so many different types of answers for that question. Okay, hopefully that kind of makes sense. And then we've got qualitative data, is multi-method in focus, involving an interpretive, naturalistic approach to the subject matter. So it's a bit broader now, okay? So we've got these three different types of qualitative data that we need to consider. So we've got binomial, which is between 2 points. So we could have a red ball, for instance, and a blue ball. And from this, we could have 3 red balls, for instance, and we could have 2 blue balls. So within that ratio, the binomial would be looking at the difference between them 2 areas. So looking at the difference between 3 and 2, which is 1. So this is one method of qualitative data that BCS highlight within the syllabus you need to consider. The next one is nominal. So that's a random selection from 1 to 2. So it could be looking at male and female to make it easy. And then within that, data can be categorized between the random selection of 1 or 2, depending what characteristics it has. And then finally, we've got ordinal. So that's a placement order. So it's not looking at numbers as in first, second, third, and fourth. It's looking at the gap in between. So imagine a race. You've got first place, which is 10 seconds. Then second place is 14 seconds. So there's a 4 second gap. Third place is 15 seconds. So there's a 1 second gap. And then fourth place is 16 seconds. So there's another 1 second gap. So you've got a 4 second gap at the front and then 2 1 second gaps. The ordinal bit is looking at these different gaps and working out patterns and trends between them to show why there was a difference between the massive gap at the start and the smaller gaps at the bottom. So these are 3 different terminology that you need to do some research on, and you need to look at and consider the different ways in which you could use these methods within data analysis themselves. So finally, we're going to look at some different terms that BCS like to use. So you've got operational and administrative data, okay? So there's different types of data which BCS want you to consider. So you've got operational data, and this is data which is used in day-to-day business operations. This data is bespoke to the company, however, is used to make business decisions and opposed to being a simple audit. So an operational element is some set of data which allows the operation or the method of operating the company itself, okay? Then you've got administrative data, which is data used for the administration and management. This is generally government-led and looks to collate large quantities of data in order to solve and inform decisions. This could be something such as legislation. So in a college format, for instance, we have different governing bodies. They might send us administrative data or different syllabuses or regulations to look at. We would then put them in place as operational data to run the day-to-day business of operations, and then from that would then be carried out. And then finally, we've got research data. Research data is data collection within the process of gathering and measuring information on a variable of interests to enable you to answer stated research questions, test hypotheses, and evaluate outcomes. So generally when you're looking at predictive analysis, when you're trying to work out something based upon a research idea or a data analyst task that you've been given, that will fall into the category of research data, because you've carried out primary research or secondary research in order to achieve something, and that then falls into research. So again, with the exam, they're probably going to ask you something around operational, administrative and research data, and it'll be up to you to understand the different terminology of these areas. And then finally, there's one more area which they need to consider within data structures themselves. So we've got open and public data versus proprietary data. So open data is data that is available in a machine readable format without restrictions on the ability to use, consume or share information. So it's open source information that we can access. However, importantly, it's readable in a machine format. So that's really important. This could be information that we take, for instance, off some stats websites to find information about students, or it could be information that you take off a film website. It's open source data that you've been given or you're allowed access to, which is easily readable. Next, we've got public data, which is data that's available to the public to collect or look at, but is not easily readable or machine readable, and sometimes not easily obtained. So this, for instance, could be some of the articles within a library that are more restricted. So you could go to a library and you could ask for this article from 1950 on this topic. With that article itself, in order to make it readable by a machine, you would obviously have to translate that into some form of structured data. Therefore, it's publicly accessible, however, it's not as easily analytically used. Thinking about stuff like legislation again, that falls under public data because it's stuff that we've been given, however, we can't read it the same and we can't understand it the same. Maybe we can as humans, but not machine readable. And then finally, after open and public, which kind of are the same category, we've got proprietary data. So proprietary data is data that is claimed ownership by a specific entity or company. So this is data that's owned by someone. So any company in the world generally will have some form of data, whether it's on their employees or whether it's on their customers or whether it's on their processes or operational data that is owned by that company. And therefore we can't use that because obviously you've got copyright and you've got GDPR and all them sort of elements. And then even if we could use that, there will be massive issues with the safety and security of it. So for BCS, you just need to consider these three different types of data. So open data, public data, and proprietary data, okay? And that is it. So hopefully within this video, you've learned some things you didn't know and you've confirmed some things that you do know as well. So we've looked at a range of different elements such as data, information and knowledge, and hopefully you've got a pretty good understanding of that now. So you've got data, which is facts, you've got information, which is processes from them facts, and you've got knowledge is more around the context of your interpretation with that information. You've got a bit of background with some typical formats that we're going to be looking at and using within this module, and also BCS highlight these as recommended ones to focus on, and I agree. So CSV files and XML formats, RTF and text, and again you can go over this list again to look at some of the benefits and limitations within these. There's also other benefits and limitations as well, but these are just the main ones that BCS would need to consider. And then you've got a basic understanding now of what structured and unstructured data is. So we've looked at structured data as being the pinnacle of data analysis, and then we've got unstructured data, which is generally where most of the data starts off, and it's our job as data analysts. When we look through the different data analyst tasks, we'll come across this quite a lot. It's our job to take that data as unstructured data and then take it to a structured level. And again, we've got some different elements to consider because of that. With the terminology and the wording, these last few slides, you just need to embed these terminology words in your head. You probably know what they mean already anyway, but it's just making sure you understand their terminology because of it. So you've got categorical, which is making categories for data. You've got continuous, which is not making categories for data, but data that would fit into a massive range of categories if we had the time to do it. And then you've got some different qualitative methods, such as binomial, nominal, and ordinal, which I want you to do some research on the three terms again, and just make sure you've embedded that into your knowledge as well, okay? So again, I'm saying embed that into your knowledge. That's based upon data and information that I want you to find out. And then we've got some terminology which we probably know anyway at the end, but it's something to consider. So you've got operational data, which is data we use to operate the day-to-day businesses. Administrative data, which is stuff we're given generally, such as legislation and regulations, to allow us to do operational elements. And then we've got research data, which looks at projects and different analysis tasks. And then finally, we've got open data and public data, which are different types of open source data, whether it's machine readable or not. So machine readable is generally open data, non-machine readable is public data. And then finally, we've got proprietary data, which looks at data from a specific company and is claimed ownership. Okay, so this covers everything you need to know within syllabus area 1. So what you should be doing now is you should be going through the revision guide and creating your own notes to make sure you're embedding all of this knowledge. And you should also be doing your own research around these different areas and just making sure you've got a foundation in each one of the syllabus stages, so that when you get to the exam and when you get to the time where you're going to be tested through assessments and all that sort of thing, then you understand what all these different terminology is, and also what the different types of different data and the different types of formats are. So thank you for listening.